Today I will cover atomic numbers and isotopes. Atoms consist of protons, neutrons, and electrons. So the protons in the atoms carry a positive charge, the electrons carry a negative charge, and the neutrons have no charge. Now in the nucleus of the atom, the protons and neutrons reside, and they make up the mass of the atom. So that means that the electrons are so small that we say the mass of the electron is negligible. Therefore, the mass of the atom comes from the protons and the neutrons. Now I'm going to draw an atom. So here is the nucleus, and the nucleus is going to have a positive charge. And the reason the nucleus has a positive charge is because that's where the protons and the neutrons reside. And since the neutrons have no charge, the only charge within the nucleus is from the protons. And on the outside is where the electrons are. And the electrons have this negative charge. Now we'll move on to the next slide. The first thing I'll talk about are some symbols that are used when talking about atomic numbers. So the first is the atomic number, and this is equal to the number of protons in the atom's nucleus, and that is denoted by the symbol Z. And the number of protons in the atom's nucleus is also equal to the number of electrons around the atom's nucleus. We want our positive charges coming from the protons to equal the negative charges coming from the electrons on the outside of the nucleus so that the atom will be neutral. Just know that whenever you see the atomic number, this is equal to the number of protons, and it is also equal to the number of electrons. The second thing is the mass number, which is denoted with the symbol A. And this is the number of protons plus the number of neutrons. So remember that our mass comes from the nucleus of the atom. And in the nucleus of the atom, the protons and the neutrons reside. This is where our mass is, which can be calculated by adding the protons and the neutrons. If you look at the periodic table at the bottom, we have these numbers on the top left of each one of the atomic symbols. So each one of these letters here represent an atom, and they each have a symbol to go with it. And in the very top left, there's numbers. And these numbers are your atomic number. And remember that our atomic number is the number of protons in the atom's nucleus, and it is also equal to the number of electrons around the atom's nucleus. So for example, in boron, which is denoted by this symbol B, the atomic number is represented by the number 5. So that tells us that boron has 5 protons in the atom's nucleus and 5 electrons around the atom's nucleus. In the next case, it's carbon, and carbon has 6 as its atomic number, and that tells us that there are 6 protons in the atom's nucleus and 6 electrons around the atom's nucleus. So now I'll move on to the next slide. Now we can see how atoms and their symbols are written. We normally see atomic numbers written as I have in these first 2 cases. The symbol, which is denoted by a letter, represents the atom. The number on top in red represents the mass number, which is equal to the number of protons plus the number of neutrons. And the number in blue on the bottom is the atomic number, which is equal to the number of protons, which is also equal to the number of electrons. If you're confused about which one's the mass number and which one's the atomic number, look at the bigger one of the two, and that will always be the mass number. In the first questions, it's asking us to calculate the number of protons, neutrons, and electrons in the above atoms. So our first case, we see the symbol N, and that represents nitrogen. And it's telling us that nitrogen has a mass number of 14, and it has an atomic number of 7. So our atomic number represents our protons. So we have 7 protons, and I've just abbreviated it with a P with a positive charge. And if we have 7 protons, that means we have 7 electrons. And we don't know how many neutrons we have. but we can calculate it by subtracting the atomic number from the mass number. Remember that the mass number is the number of protons and neutrons, and the atomic number is the number of protons. So if we subtract the two, we can get the number of neutrons. So 14 minus 7 is 7. So that tells us that in the nitrogen atom, we have 7 protons, 7 electrons, and 7 neutrons. So now we'll do the same for the symbol Ca, and this represents calcium. So calcium has a mass number of 40 and an atomic number of 20. So that tells us we have 20 protons, and if we have 20 protons, then we have 20 electrons. And our number of neutrons is the mass number minus the atomic number, which is also 20. The last thing I'll talk about for this video is isotopes. And isotopes are atoms with identical atomic numbers but different mass numbers. So isotopes between two atoms should have the same number of protons, the same number of electrons, but the mass number will be different. So that means that they'll have a different number of neutrons, which can either add to or take away from the mass of the atom. In the first example, I have the symbol N, which represents nitrogen. I put nitrogen here so you can see the difference between the mass numbers in this above nitrogen and in this new nitrogen here. In this bottom nitrogen here, the mass number is now 15, but the atomic number is the same, which it should be. The atomic number should never change. If the atomic number changes, then it is no longer a nitrogen atom. So in the first case, we have 7 protons, and if we have 7 protons, we also have 7 electrons, and our neutrons can be calculated by taking 15 minus 7, and that will give us 8. So we have 1 extra neutron, which is giving us 1 extra mass unit for nitrogen. The next example we have is the symbol U, and that represents a uranium atom. And for the uranium atom, we have a mass number of 235 and an atomic number of 92. Our protons are 92, which means our electrons are also 92. And if we take 235 and we subtract 92, we can calculate the number of neutrons. And that will be 143. The very last symbol is Se, and this represents a selenium atom. And the selenium atom has a mass number of 75 and an atomic number of 34. So that means selenium atom has 34 protons, 34 electrons, and the number of neutrons can be calculated by taking 75 minus 34. So the number of neutrons is equal to 41. That will conclude the topic over atomic numbers and isotopes.